Hello students, in this video we will learn insertion in doubly linked list at first position. There are three types of insertions we can perform over doubly linked list. We can insert node at first position. Here we can insert a node. Insertion at last position, that means we can insert a node at last of doubly linked list. We can also insert node at a specified position in doubly linked list. Here you can see we can insert node at second position, at fourth position, that means in between the doubly linked list. In this video we will learn how to insert node in doubly linked list at first position. So first logic is case 1, when doubly linked list is empty. When doubly linked list is empty, the value of L and R equals to null. We have to create a node P, and this node will be the first node of the doubly linked list. As we know that in doubly linked list there are two pointers are required, previous and next. Previous pointer store the address of previous node and next pointer store the address of next node of given node. So we have to declare a struct like this to create a node. Data is of type integer and two pointers of type node. Then we have to create a new node P equals to new node and store value that you want to store in data part of P node, as this node, this new node will be the first node of doubly linked list, as the doubly linked list is initially empty. So store null into previous pointer of P and also store null into next pointer of P. Initially L and R is equals to null, so we have to point L and R to this node. As we know that L is the pointer which store address of first node in doubly linked list and R is a pointer which store address of last node in doubly linked list. Initially they both contains null value, so we have to store the address of P into L and R. So I had written L equals to P and R equals to P. Now linked list contains a single node which is pointed by L and R. Case 2 is when doubly linked list is not empty, that means value of L and R is not equals to null. This is the doubly linked list containing 3 nodes. We have to insert new node P at the first position. So what steps we have to follow? First we have to create a new node, then store data value into data field of the P node, P arrow data equals to 50, as this node will become the first node of this doubly linked list. Then in previous pointer of this node we have to store null because there is no previous node of this node available. So you have to write P arrow previous equals to null. Students, one thing you have to remember that whenever you perform insertion in singly linked list or in doubly linked list or in circular linked list, first you have to initialize the new node. After that you can change the pointers of other nodes, otherwise you will get the wrong results. As this node P will become the first node of this doubly linked list, then this node will be the second node of the doubly linked list. Initially this one is the first node of doubly linked list, but when we insert P into doubly linked list, this node will become the second node of doubly linked list. This node, as we can see, address of this node is 100 and this address of first node is stored into L pointer. So we have to write P next equals to L. Now P is pointing to this node. Then we have to change the previous pointer of this node into address of this node, as after insertion P node will be the previous node of this node. So this node is L. L previous pointer is equals to P. So I had written L arrow previous equals to P, that means the address of this node 800 will be overwritten over the previous pointer of this node. Now this node pointing to P node. Now This node is the first node of doubly linked list, so we have to make this L pointer to point to this node. So we have to write L equals to P. Initially L equals to 100 because this is the first node of the doubly linked list, but when we insert P node will become the first node of this doubly linked list. So we have to change the value of L by 800. So I had written L equals to P. After insertion, the doubly linked list contains 4 nodes. First node contains 50 value, second node contains 10 value, and third node contains 20 value, and fourth node contains 5 value. So algorithm name is insert underscore first. That means we are inserting first node in doubly linked list. Here we require 3 parameters L, R, X, where L is pointer to first node, R is pointer to last node, and X is value to be inserted. Here we are also using 2 pointers inside a node. Previous pointer stores address of previous node and next pointer store address of next node. Purpose of this algorithm is it inserts a value at first position in doubly linked list. Step 1 is create a new node from memory. When we want to insert any node into the doubly linked list, then first we have to create a new node from memory. So we have to write P equals to new node. If P is equals to null, that means there is no empty node available in memory. So we have to print no empty node available in memory and exit from this algorithm. If there is empty node available in memory, then address of that node will be stored in P. So first we have to initialize the new node. So step 2 is initialize new node. We have to store X value into data field of P. So we have to write P arrow data equals to X, and as this node will become the first node of this doubly linked list, we have to write P previous equals to null. And step 3 is if doubly linked list is empty, then new node P becomes the first node of doubly linked list. So we have to check the condition of empty doubly linked list. If L equals to null and R equals to null, then we have to make P next equals to null, L equals to P, R equals to P, and exit, as we do in this logic. But if doubly linked list is not empty, and store address of first node into next field of P. So we have to write P arrow next equals to L, and in step 5 we have to update the previous pointer of first node by address of new node by writing L previous equals to P. And in step 6 we update L pointer by address of new node by writing L equals to P, and step 7 is AND, as we saw in case 2. So all these steps we have to perform when the doubly linked list is not empty. In next video we will learn insertion of node at last position in doubly linked list. Thank you.